Okay, thank you for coming. Happy Tuesday. I really appreciate you being here. You've got back your your unit 1 packet. Just hang on to that. There's a chance that some of the earlier ones were more just to help get you started. Some of the later questions might show up on a quiz or exam at some point. So maybe hang on to it if you want to use it to study. My announcement is that lab 1 on Canvas, I believe, is due today. And so make sure that
I thought it was due on Thursday.
I said that at one point. I decided to make it due today instead to give you extra time. If you've already done it, then that's great. But in case you need some extra time between now and 11:59, you've got it. I will say that lab 1 is very, very important. So although it's worked in teams and only one of you needs to submit the code, both members of the team should fully understand what's going on. Lab 1 is really important. It's the first
Oh,
step.
wait, sorry. I thought you were talking about homework 1.
Oh, no. When is homework 1 due?
I used to go Thursday.
Thursday.
This Thursday.
Okay. Great. Thank you for mentioning that. I had forgotten about homework 1. But back to lab 1. It's really important that even if your partner wrote some code, that you know that you could have written that code on your own. It's really, really important because I don't want so the thing that I'm afraid of happening is if you're in a 2-person team and maybe you have no idea what's going on this week, and the next week you're in a different 2-person team and you still have no idea going on and your partner just does all the code for you. That's what I don't want to have happen. I want each and every one of you to be able to write things in Java. And so you being able to know what's going on in lab 1 is really, really important. So even if you've turned it in at any point, you can always, hey, how's it going? At any point, you can always come in and talk with me and be like, I'm really confused. I need help. And I'm happy to help. So make sure that you're utilizing the skills, come to office hours or make an appointment with me. Go to the STEM center, talk with your classmates. I want to make sure that you are on track to learn this stuff. Okay, so the moral of the story is if you're confused on lab 1, and then you need to come talk with me or talk with a classmate or a peer. If you're good on lab 1 and you're like, I've got a fair idea of what's going on here, then you're good. Homework 1 is due this Thursday. That's on Canvas. And yeah, so if you have questions on how to get started on that, come talk with me. I'm happy to help. I have office hours tomorrow. Ten to 12. Or you can book an appointment and I'll be available then too. I don't think, incidentally, I don't think office hours shows up as an availability tomorrow. Yeah, it kind of skips until 12. So show up in office hours or book an appointment outside of that. Okay, I think I'm gonna give you another day to for me to go over lab 1, just so you can finish it up. And then after the due date, then I'll talk about it of here's what's going on. So not to give you the answers now is the main idea. Okay, we're gonna start unit 2. And unit 2's topic is more Java. All right. So The things we're gonna cover in this unit, we're gonna talk for a little bit about why we're doing Java, what's kind of the history of Java and how we got here. We're gonna talk about some of the other finer points that we kind of glossed over in the initial, here's how we get you to write a while loop, here's how we get you to write a for loop. Those kind of things. We're gonna talk about methods. We're gonna talk about reference variables. We're going to talk about array reallocation for a lab 2 problem. We're also going to talk about what are called lists, which kind of let us overlook the reallocation problem. We're going to talk about strings and a different kind of for loop. Okay, so first of all, talking about who made Java, there's these 3 guys, James Gosling, Mike Sheridan, and Patrick Naughton. I think James Gosling is one of the main guys. They started working on this in 1991, and then they first released it in 96. So they spent 5 years working on this language before.
Mine won't load.
Which one?
CS222 U2 more Java.ppx.
Did you try downloading the file?
No.
I would try downloading the file and then you can open it in PowerPoint. Sometimes Canvas takes a long time to load things. So that's just a point of like, if you're in class, how long does it typically take you to work on a class project? Maybe like a semester. These guys were working on this for 5 years. So to start off, these guys worked for a company called Sun Microsystems. So Sun sold computer parts and software, Java being one of the software parts.
You could say it sold. Get it? Because
That's a good one. I like that. That's awesome. The next part of that journey is the Java virtual machine. That's the thing that actually like runs the code that we write. That was made open source in 2006. I have, I think I talk a little bit about that in a bit. So thinking about like what open source is when you like release it for anyone to download, use, change for their own purposes. And then they could re-release it, they could sell it as something. So they released the Java virtual machine as something that's open source for anybody to use in 2006. In 2009, Sun was acquired by Oracle, which sounds a little bit like a Percy Jackson plotline. Oracle is a company that still owns Java. Oracle does cloud computing. They have database software and stuff for businesses, enterprise stuff. Something that we'll talk about is there was a lawsuit between Oracle and Google when Android was first developed. And then the founder of Java resigned from Oracle after they merged, and Oracle is still going. So a lot of if we look up like, say we look up Java documentation, the people who host this is Oracle. So they still own, or like they bought Java, and so they've still got it. That's the people who have the documentation, and that's one of the people where you can download Java from. So we downloaded it from somewhere different, but you could have done it from the source, from Oracle. In terms of what Java is used for, initially it was a lot of interactive web applets. So back in like earlier days of the internet, there were, these are things that have mostly gone out of style. There's pages on the web where you can, I don't think I have a picture for that, where you can play games or do some sort of applet. Now it's used a lot for cloud computing and databases and a bunch of other stuff. Like it's also just a regular programming language. So a lot of applications can be written in Java. Something to know about Java is so we need the Java runtime environment, the JRE, to actually run stuff. Something that's fairly common is that Oracle can be slow in patching things. So if there's a vulnerability, sometimes it can be slow. And so in that sense, that you'll sometimes hear like Java is insecure because maybe it takes them a while to patch it. You'll hear about a Java vulnerability every once in a while. The last one I remember hearing about was because some Minecraft server found some
Oh, the
loop.
Log4j exploit.
Yeah, Log4j.
It's kind of what it happens. Exploits like these happen all the time on the Anarchy server that is heavily involved in it.
Mhm.
Well, yeah, but they were using like arbitrary code execution to like hack people's computers. There was like some wild stuff like
Yeah.
Java loophole to gain access. I don't know how they did it, but basically if you type a random string of numbers or letters in a certain order, basically just gave you like complete free access to someone's computer.
Yeah, incredibly scary. And it's because of a vulnerability in Java.
It
So-
wasn't even the only incident like that in 2020. Have
Mhm.
you ever heard of Phobos?
I don't think I have.
Okay, never mind then.
So yeah, so sometimes you'll hear about things like that, which makes you think that Java is insecure. That's the process of security, where you try to plan for everything in advance, but it's inevitable that you're gonna miss something. So someone's gonna find something, and then you try and patch it as quick as you can, and then continue on, and the cycle continues. So one of the questions I got last semester is like, why are we doing Java? Which is part of the reason that I'm telling you about this. Facebook/Meta, Apple, Amazon, Netflix, and Google, they all still use Java to some degree. Like there's a bunch of applications for cloud computing, databases, and a lot of the financial sector have a lot of their old code bases in Java. And so the thing about once someone writes their code base, it's a lot of work to rewrite all of that in this new language that comes along that's a million times better. So it's good to know for going into different companies if this was the standard for a while. Okay. So the thing about Java's early history is that Sun Microsystems owned the Java language. So what does that mean? You needed a license for Java written software to be signed. So for the people with Macs, you know how sometimes when you download a program from the internet, the Finder or the settings will pop up and be like, this program isn't signed. You may not want to trust it. It's a way of verifying that like this is a legitimate program. So yeah, so the way that worked is that so companies needed to like pay to get a license and then they can distribute their software. And then Sun was acquired by Oracle, which kind of changed things. So one of my questions for you to think about is why would code be copyrighted? Then the other one is, do you think a programming language should be open source? Open source meaning anyone can download, modify, reuse, and maybe sell it without paying for it. So I just want us to think for a second of what are some situations for this. What do you think about code being copyrighted or royalties? So like someone paying you to use your code, or open source. Think it's a good idea? Think it's a bad idea? I'll give you a second to jot down some thoughts and then we'll discuss it for a second.
Are we writing in the packet right now?
Sure. Yes.
But do we have to do it like right now? Because like we've yet to answer the first question.
So for the first question is just what thoughts do you have about it? And then we'll talk about it in the large group. So first write down your thoughts and then we'll discuss it. Okay, everybody get a chance to jot something down? We can keep taking notes as we go. So I'd like to spend maybe, I don't know, 10 minutes or so having kind of like a seminar discussion of what do you like, let's start with the first one. Why would code be copyrighted?
Because people are stingy.
Because people are stingy. In what way? What does that mean?
They don't want, they don't. You don't want people, using their code to, make things that they don't want.
So kind of putting limits on what it can be used for. Any other ideas? How would code be copyrighted? Yeah,
It's a lot of time and like money, not so much these days, but at least in the past, it took a lot of money to print the code, like at a high level.
yeah,
Where it gets into that.
yeah. Like the guys who developed Java spent 5 years working on the language. And so if they copyrighted that, that helps them to get paid back when it's used in the future. Other ideas?
I was kind of thinking like kind of similar to what we were talking about. I was thinking about like in terms of like verification and like protection for like intellectual property. But then I was also thinking for the user as well, because like I'm thinking that there's like a lot of like malicious like code out there for hacking and stuff. So I feel like the copyright's like protection for both parties.
Yeah, like if you're paying for some software that's copyrighted, then you know that this is like a trusted application that you're downloading. And the person who's selling you the application is like, yeah, this is what you want. I'm gonna give it to you. And I'm gonna get money, you're gonna pay for it. So there's peace of mind on both sides. Yeah, I like that answer. Any other thoughts?
And it's like the code being used to be like something like, right, for like the government or something, like if that kind of gets open source, like gets out, kind of might mess up like what they're doing.
Yeah, so there's some element of like trade secrets that maybe we're doing some super secret special thing in our code and we don't want to let anybody else know what we're doing. And so if we made this code open source available to anybody, then that's a problem. One of the examples I have for this is I'm working on like a journal paper. So I've written code and wrote a paper about it saying, here's what I did. And I am planning to release the code so that people can test it and do things. but I'm keeping it private and not releasing it anywhere until after the paper is published, right? So I don't wanna give everyone the code and then someone else can like steal it and write about it. I'm gonna keep it protected for now until later when I can release it. What are your thoughts about open source? So talk about how like copyrighted and like paying for code makes sense for peace of mind for the user. Recoup expenses for the developers. Any other ideas?
Removes barriers to entry, so anyone can learn how to code. If it's
Mhm.
open source. I'm a data science student, so I use R, which is open source. But the industry standard programming language for statistics is SAS.
Mhm.
So it creates like there's a barrier of entry. It's not always one-to-one.
Yeah. Yeah, that's a great example. Yeah, like someone put the energy and time, and sometimes it's the question for industry standards, sometimes it's the question of who got there first. So I'm willing to bet that maybe SAS got there first.
Yeah, it's been around since it's been a while.
Yeah, yeah, so sometimes it's like, this is the way we've always been doing it, and we charge for this, so oops, oh well, versus the open source of anyone can do this, let's try. Any thoughts about open source or royalties? Yeah.
Yeah, for me, I said that like I'm specifically for programming languages, like I'm pro open source. Because like I feel like it like allows more people to like use it. And rather than like having people like being like gate kept from like, being able to like learn how to like code or coding. Cause like I feel like if you have to pay, like then it's kind of like, oh, well then like I feel like it doesn't like democratize like things, and I like, at least to me, like I like the idea, like for me, like the idea of coding should be like democratic, and like it can like allow for like inclusivity of like different like perspectives to be able to like operate and write code.
Yeah. Yeah, that makes sense. I also think of like software applications. Oh, sorry. Go for it.
I'm just gonna say for the royalties, it probably gives people an incentive to continually improve on what already is there.
Yeah, yeah. Yeah, I was thinking like, because if you write this super special app and you release it for free, there's, I mean, that's great for all the users, but you got to think about what, like server costs. You got to think about the time and energy it took to invest to make that app. Whereas you, on the other end, you've got something like Google Docs, which make these applications that anyone can use for free, but where are they getting their money? From like advertisements and stuff. So there's trade-offs there, right? Yeah.
Well, I think most like big applications, like applications that kind of like push technology should not be, it should be open source, because then other people can learn from it and they can improve on it. And generally, I think, especially if you have something like revolutionary, like a whole new coding language, or even like stuff like AI, like it should be open source, because then people can be like, hey, this is really, like, let me try this, let me try that. And then people can take those things and make it better. So when you copyright that kind of stuff, it's just greed. But like smaller applications, like apps, or like, I don't know, like a small little program that you have fun with, or maybe like like, maybe something that deals with like personal information, like you probably wouldn't want that out there.
Mhm.
So like you would have that be not open source.
Yeah.
Or if the code just really sucks and you don't want anyone in your job.
You gotta pay me for this. Yeah. Any other thoughts? I'm thinking in line with your comment, anybody heard about DeepSeek? Where that's like the open source AI as opposed to OpenAI, which is not extremely open source. And so the question is like, how, like, which one is better? Like, you gotta pay OpenAI to do a lot of really complicated things with their stuff. So it's, even though it's OpenAI, it's not open source per se.
Pretty sure DeepSeek only costs like 6 million a meg, so it was like way cheaper and it performs the same, like. It sometimes performs better
Mhm.
than a lot of the AI models, and also it's free and doesn't suck. I mean, I don't know, I never tried it, but like,
Yeah.
also, it has, I think it has Chinese censorship, so like, if you ask her about Tiananmen Square, I won't tell you.
Hmm. Yeah, so,
People have gone around it though.
yeah, so there's some drawbacks to that too. Yeah. Any other thoughts about copyright royalties, open source?
I think like for someone that like might have to use like different like languages, like I think it would like really like suck to have to like pay for each of like the different like languages if it wasn't like open source.
I think there might be a difference between like learning the language and like the publication of applications. So I think that's the thing about like where Java started, where like anyone can learn it, but they have to pay for a license in order to sell their applications that they made. Yeah, I think that's my minor point to that. Any other comments, thoughts? Cool. Thanks for that discussion. Oh, wait, I had more. So about Android, this is kind of where the lawsuit comes in. So Android apps used to be pretty much exclusively written in Java. Now they've kind of transitioned to a language called Kotlin. Kotlin? Google used a version of the JVM that they made. Therefore, they didn't need any license from Oracle. But once they released that, Oracle was like looking over to their paper and be like, hey, you've got similar things over here. You violated our patent.
Objection.
Exactly. And so Oracle ended up winning at least part of it, because some small amount of code looked like it had been copied. But this gets resolved in 2021, where the Supreme Court is like, nah, Google, you're good. It's fine. Okay, so this was a better setup for the discussion, but we got there anyway. Yeah, so I hope you continue to think about this. Like, when you design some sort of application, do you want to sell it or do you want to make it open source? What's your end goal here? I think these are important questions. There's like because there's like the I need to make money side of things, and there's the I want to contribute to like computing as a whole side of things. So I think it's a trade-off that you personally need to consider as you continue your computing career. Okay, that was my tangent. Now it's time for Java. Okay, so let me make sure that I open Eclipse. I'm going to make a new class for today. So again, that's top left. Click on the little sheet with the little plus.
Are we going to be making a new class instead of a new project for every in-class assignment?
A new class instead of a new project. So my idea is each day in class or each topic, I'll have a new class to test things out. But I want all of that code to live in my in-class project. Like the project is what collects all the code together. Okay, so I'm gonna, since we're not in the basics anymore, no, I'm gonna do U2 more Java. That's my package name because now we're in Unit 2 more Java. So again, that's the package name. The source folder stays the same. CS222 in class. And for the class name, because it's February 18th, I'll call it capital F Feb 18. All of these things we can ignore. I will click on public static void main.
Hang on. Wait, are we creating a new class?
Yes,
What do we name it?
I named it February 18th with a capital F, but you can name it whatever you want. Okay, everybody good? Cool. Okay, so now I'm in my package, U2 more Java, or if you chose to leave it in basics, that's fine. And I've got my main method all set up, ready to run things. Okay, so previously we installed Eclipse, a way to write and execute Java. We also installed Java. We learned how to print stuff with println or printf. We learned about variables, how we can declare variables, how to initialize and do some math with variables. We looked at for loops and while loops. We also looked at logic, so that's the if, else if, and else. And then we looked at arrays as well. So that's kind of where we're starting. Now we're learning a few more things. So we're going to look at a conditional operator that's allows us to do if and else a little bit faster, maybe. We're going to talk about what methods are. We're going to talk about comments. Now that I'm looking at the slides, I don't remember if I actually included slides about comments. No, I don't think so. All right, I need to update this. I'll update this slide deck and then re-upload it. And then on Thursday, we will be good. Let me write a note for myself so that I remember. Actually, let's just talk about it now. So you've seen these comments that at the beginning of the main method, right? Where we have some double slash and then everything after that gets ignored, right? There's also what we call a multi-line comment, where if I type slash and then star, and then I hit enter, it gives me something like this, where I can type things on multiple lines and all of it is not code that gets executed. Do you have a question?
No.
Okay. So this is helpful for maybe explaining if you have like a paragraph or something that you need to write an explanation for some code that just happened or that's about to happen. Then you can have a multi-line comment that says something about this in more detail. that's more than just like a single line. There's also something called a JavaDoc comment, which is special because we can write it with a slash and then 2 stars. And then, so inside the method, it doesn't really do anything. It's called a JavaDoc comment. Inside the method, it looks no different from just the regular multi-line comment. But if I type it before a method, so slash star star, then I hit enter, it autofills with something. So it autofills with @param_args, which says, I've put it before a method, a function, and so now it's gonna try and tell me information about this method. So let me say this is my main method. And now if I hover over the main, something pops up here where it says, this is my main method. I typed those words. Java didn't type them. Eclipse didn't type them. I typed them. And so JavaDoc_comments lets us write documentation for the Java code that we write. So it lets, when we're planning to release this code to other people, it helps make things clear of, I can say, this is what my main method does. So maybe to be more clear, I could say, main method for testing, February 18th, 2025. That's a description of the code that I'm going to write in this class. And so then if I hover over that, then something else shows up, the things that I just typed. So that's comments. So you'll notice that even if, so like say I wanted to add some code here, like system.out.println, I can't because it's still in that multi-line comment. So the thing with multi-line comments and JavaDoc_comments is it knows the start symbol and everything until it gets to the stop symbol, which is the */. That's gonna be, that's gonna, oh, thank you. Once we get to the */, then the multi-line comment has stopped. Let me see if I can also. Hold it. Okay, hopefully that's also visible. So yeah, so I can, until we get to the */, that's when we know, until we're in there, we are in the multi-line comment. Okay. The assignment for this unit is just going to be lab 2, which once we get through this slide deck, then we'll work on it. You can start it early if you want, but I'm going to, once we get through this slide deck, I'll assign teams and then you can work in pairs to do those. Okay, so there's some sneaky shorthand that you should know about that exists. So there's the long way of doing things where you have if parentheses and then some condition. So let's say if we've got X is 5, and then we'll say, or wait, no. What do I want to do? Let's make it actually Boolean cool is equal to true. And so then we can set up an if else statement to say if cool is true, then print you are cool. And then otherwise, we can do you are not cool. So if we run this, we set cool equals to true, and so it will print you are cool. Fun fact, you don't actually, for the condition, you don't actually need if cool equals true. You can just say if cool. Because the cool variable is a Boolean, which is either true or false. And so you just need to say if cool for it to work. Okay, hold on. Where's the error that lives here? That way it won't keep telling me there's an error. All right. So everybody good with this? This is how we write a simple conditional, if and else. There's a shorthand way of doing this where so the general way is to say if some condition, then do this if it's true. Otherwise, do this if it's false. We can condense that to all in one line where we can have some result and we say, we have our condition, then we have a question mark. And then we do this if it's true, colon, do this if it's false. So let's try it out. So another way of doing this is cool question mark. Do if true, so we'll print you are cool. Otherwise, we've got the colon. I gotta print something here. Okay, is that gonna work? No, it's not gonna work. Just a moment. I'm also figuring it out. Okay. So I had an issue where if I just say cool question mark, print this, colon, print that, didn't like that. So my alternative is I know what string I want to print in either case. And so I will assign it to a string variable on the left-hand side. So my result equals the result of this. So the equivalent would be So they're two equivalent things, right? So either I could print it out here, or I can assign it to a variable and then print it somewhere else. And that gives me an error. I just assign it. Oh wait, no. I know the issue is I commented out the wrong line. There we go. Okay, I'll let that sit for a second. You have a question?
No, I do the shorthand.
So it's, if you have a string variable, so string to print equals capital S string. And then the variable name is to print equals. And then your condition is cool, or okay, you've got. Then question mark. And then after that is what your string will be equal if it's true. Which is, I am okay. So quotation marks, I am okay. And then colon. And then this is the thing if it's false. This is the else. Yeah, and then you just need a semicolon at the end. Here. Anybody else need help with this? Yeah.
Okay,
Yeah, oh, sorry, it's,
Says I don't have a variable to print.
you don't have a variable. No, you do have a variable. That's just a warning. I've got the same warning, or I will once I comment this out. So if I didn't have the actual print line, I get a warning saying the value of the local variable to print is not used. That's basically them warning, hey, you've got this variable. Are you going to do something with it? So if I uncomment the thing where I actually print it, now I've done something with it and the warning goes away. Okay, we're good? Okay, but yeah, so on the right hand side, just make sure to close the string and add the semicolon. Make sure that you close the string and add the semicolon. If you don't have errors, then you're probably good.
I still have the warning.
So try printing the string variable. Do sysout, control space, and then print that variable. Okay. So that's just something that I think you should know, something that exists that you can use if you want to. I encourage you, if you're in a situation where there's only an if or an else, consider doing something like this. So we've got to talk about methods. So methods are ways of like compartmentalized doing something. Methods, like functions in Java, are some bit of code that does something specific, right? In other language, we call them functions or procedures. Java calls them methods because reasons. The reasons are Java is object oriented. This is a main thing that we'll cover in this course. And everything in Java is either a class or part of a class or related to a class in some way. And so class functions inside of a class get called methods. So in terms of things you should know about methods, this is kind of um, the bare bones, here's what a method is. So there's things that go, so let's start with visibility. We've got visibility, static, return type, name, some parameters, and code statements. So let's talk about visibility first. So far, the methods that we've seen in our code, like we've got one in our code right here. This method is public. We've got public static void main. Public means that anyone in any file can use or access this method, which makes sense. I would want someone to be able to use the main method. There's other options. We could have private, which means that no one outside this file is going to be able to access or use the method. There's an option where we have nothing to, so that means package visible, which means anyone in this file and any code in the same folder, so in the same package, can use and access this. So like for, let's see, for hello world.
So so this bill, for example, would be public or private.
Public, private. There's also where you don't type anything, and that's package visible. So no option is also an option. That's called package visible. And then there's also an option for protected. Protected means only this file and subclasses can use it. We'll talk about what subclasses are later. Okay, so that's visibility. Then there's static. And this is where I'm going to kind of gloss over some things as we are starting to get up to speed on terminology. So our code lives in a class, right? So I can have a class in the lab. There's a class called middle. There's a class called beginning. There's a class called end. My classes in this project are called, I've got a class February 11th, got a class Hello World, got a class February 18th, right? That's the title, the name of the class. A class is a thing, and we'll talk about this in a little bit as well, where sometimes when we use our class code, we create an object of this is, so in a bit, we'll look at a house where we make a house, a class called house, and then we'll actually make a house object in code. And so sometimes we need to actually make the object. Other times we don't need to make the object, which is the case for like this. We don't need to make a February 18th object. And so because of that, when we have static methods, it allows us to work without creating an object. So this is a point that I'm touching on now and expecting this to be confusing. As we get more comfortable with the language and start object-oriented programming, hopefully this will become more clear as we go. So that's kind of the overview of what does static mean, because we've got public static void main. Okay, so we've got our visibility, we've got maybe statics there, maybe it's not. Then we have return type. Return type is just, here's the kind of thing this method returns. So the question we ask is, do we need to hand some result off to whoever called this method? If we do, the type of that result, so what kind of variable it is, that's going to be our return type. If we don't need to return anything, then our return type is void. So main has to be a void return type. And so then the method names are going to start with a lowercase letter. It's similar to variable rules, right? Where variables are kindly requested to start with a lowercase letter. Then after that, uppercase numbers, underscores, fair game. So there's a packet problem for you of here are some methods. What's the return type? What's the method name, visibility? Is it static or not static? Oh, the other thing I need to mention is parameters as opposed to arguments. This is something that even I will get mixed up on, but I want to tell you so that in hopes that I will actually start using the language correctly. You may hear parameters and arguments. When you define, like, here, let's write this function in Java, where we take in two numbers and then we add them and we return it. So let's make a method in my class here. It's got to be static. And we'll call it add. And we'll take in two numbers, A and B. And then I have my curly brackets, and then inside my curly brackets, this is where the code goes. So I'm going to return
Quick static what?
int, int.
Let's see what's on.
It's add, add, int, and then in the parameters are int a, comma, int b. Okay, so it's a very simple method, right? It takes in two numbers, adds them together, and I'm going to return that result. So let's actually use it over here where I say, hold on just a moment. So add, so I'm giving two numbers that I can add together, 3 and 4. Okay, so I can call the add method and then I want to save it to some variable. That's all well and good. And then later I can print my sum variable. Another way I could do this is someone give me two extra numbers. 2 and 1. I could just say print and I say run this function and it'll run the function and then give the number to print and it'll print to the console. So if I run this, 3 and 4 get added to 7, 2 and 1 get added to 3. So this is, there's a difference between me defining here's what the function means in general to add two numbers, and then where it differs is here's me calling the function to add two numbers. Okay. Oh, so the method has to go above main. So what I've got up here, I'll walk around. So I've got public static void main. And above that, still in the public class, February 18th, that's where my method lives. Let me walk around to make sure people got that.
I could,
You want me to go back down?
yeah.
Mhm. Okay. Oh. Mhm. Oh, yeah. Mhm. Great. Mm. Yeah, sometimes saving the file makes all the errors. This is the method.
I have, one other this one, if you're in the house.
So. I think that's technically not wrong. You're also not. Yeah, you also don't have a minimum. In the class, that is. So that's probably.
That goes.
This is the file that you're given. I'm sorry if I need a name method. That's yeah, and then, so public static void main, this sets up, here's all the code I'm gonna run, and then outside of that, I've defined an additional method. Yeah. Yeah, okay, now that I've actually made a method, we should probably talk about what this actually is. So now that I've made a method and used it, in my original function where I say this is the blueprint for adding two numbers, these are the parameters. So A and B are the parameters. It helps if I can spell parameters correctly. So A and B are parameters here, where I'm defining the function. And then later when I go to use it, so if I do add of 3 and 4, 3 and 4 are arguments. They're the concrete examples that I use when I'm testing this method. So yeah, so the parameters on the packet problem are like the things in
This is
parentheses.
that too.
No, this is the packet. The unit 2 packet, problem 2. Okay, let me finish walking around and make sure people got it. Talk to you guys. Talk to you guys. What's going on here?
What was the thing about underneath? You run the first system on, what was the second one?
Just add 1, 2. Yeah, so either you save it to variable and then print the variable, or you just save it, or you just like call it when you're printing. If sum equals add, import. I don't see the add method. Yeah, so not inside the main method, but outside of it. Yeah. So it's, we have to say, here's the visibility, so public static. Yeah, and then now we have int add. And then we've got our parameters, which are A and B, and we have to say, here's what type. Yeah. I'm going to do it in a minute. Okay, so you've written the function in the main. No, this is, So the problem is you're doing this, I would move all this testing code into main. So main's up here. Yeah, no.
This one. Yeah.
Are you able to get it? Right, yeah, either it's static or it's not, so if static doesn't show up, then it's not static. House, yeah, house is.
There.
Yes.
That might be-
So for the first one, is it, what's the visibility function? Mhm. And then is it static? Is it, what's the return type?
Void.
Which means nothing. And then what's the method name?
Next boolean.
It's boolean or whatever that means. And then the parameters are. And then we've got empty parentheses, so if there's no parameters. So it's just, this is just practice in identifying what's return type, what's the method name. Learning how do we read this method signature, what is it called? So yeah, I will note that the ones in problem 2, those are all what we call method signatures of this is information about the method. So knowing what its visibility is, knowing whether it's static, knowing its return type and the name, those are all important things to know.
This one.
Which one?
Inside.
Private house grow. Nope, that's not what I called it. That's what I called it. For this one, let's crowdsource this. What's the visibility of private house grow? Private. What's the return type? House? Is it, or let's go in order, I guess. What's the method name? Grow. Talking about visibility. Is it static or non-static? Non-static. So if static doesn't show up, then it's non-static. What are the parameters? House A. Yeah. So hopefully this feels a little bit, once you get the first view, hopefully it feels a little bit like, duh, I know how to look at this method signature and see what's going on here. So it's basically taking what we know of how a method can look and just pulling in pieces of these example methods. Okay, I'll give you maybe 30 more seconds. Do as many as you want. We want stretch break. Maybe. I'll give you till 4:40. We've got 2 minutes. That's not helpful. It's 4:38. Yes.
Visibility if there's nothing.
It's called package visible.
Oh.
Yeah. It's what we call package visible. Package visible means so. Like, so let's take, for example, like I've got these two files. If I had this function in, let's say I had it in February 11th, and I didn't define its visibility, then this method is package visible. So what that means is that I can call this out of add 5 and 6, no problem here. I can also call it over in Hello World. I just need to say where to find it. So since my add method lives in February 11th, then I can say feb11.add. And even though it's not defined in hello world.java, I can access it in hello world.java. So package visible, but let's see, I can't do something like feb11.add. Where that makes an error. We'll talk a little bit more about like what package visible means. Okay, any other questions before we move on? Okay. All right, so Java allows us to do something called overloading. So overloading means we can have the same name and different parameters. So And we've got our add method over here. So let's try something, public static int add. I'm having a method with the same exact name. But let's say int A, int B, and int C, where now, instead of adding only 2 numbers together, I'm adding 3 numbers together. So it's a different number of parameters. And so now I can say return A plus B plus C. So that's my method that I can say add is now overloaded. So we have 2 methods that have the same name, but they have different numbers of parameters. So one only has 2 parameters. The other has 3 parameters. And this, what we've just done, is something called overloading. Anybody need more time to write this down? Okay. So it should be right next to your add function. So now if we go down and test it, let's add 4, 5, and 6. I'll be there in just a moment. So now when we test it, now it adds 4, 5, and 6 and gives me 15. That's great. The compiler automatically inferred. I gave it 3 numbers, and so it goes and chooses the add that's got 3 parameters. This is called overloading, where we give it the same name, but a different setup. Okay, how can I help? Yeah, you copy first, and then just add like in C. And then A plus B plus C. The table is dusty over there. All right, cool with that? Let's do another example. So let's say I want to find the maximum of 2 numbers. Maybe we can use this handy tool that we talked about. So let's add a new method up at the top. So still in my class for today, but outside any of the additional methods that I've created. So I can say public static int max. And let's say int A and B. Just a note that if I didn't have the int in front of A and B, then it gets mad at me, because in Java, this is like a recurring theme where we need to know what type of thing we're working with. So we need to know what type is A, what type is B. And so it's going to get mad at us if we don't say that. So we need to say int A and int B. And so then to do that, we need to return either A or we return B, right? So one of them is bigger. And if they're equal, then we just return, like if I ask for the max of 3 and 3, I would expect to get 3 back. So maybe we'll just choose one. So how do we write this just with conditionals? So if what? What do you think? How do I find the max of two numbers?
If A minus B is greater than zero.
And then else return B?
Or A minus B is less than zero, then if it's zero, you can return their equal or something.
Yeah. Yeah, so because my return type for the method has to be an int,
But yeah, both are the same.
yeah, so, yeah, so if like I ask for a max of 3 and 3 and I get 3, do I really care which 3 it is? Maybe not. Yeah, another way of saying this is just like if A is greater than B, so A minus B greater than 0, great way to do it. Another way to do it is if A is greater than B. That works too. You'll notice that I didn't have any curly brackets around this if statement or the else. That's allowed, but with a large caveat where if I don't have any curly brackets, then only one line is gonna be associated with the if statement. So if later, so maybe I say I want to print A is bigger, then this return A is going to happen regardless. And then this gets flagged. It says syntax error on token else delete this token. What that means is this is unreachable. So it's not a very helpful error, but after it's like the return was indented. So when I have an if else block and I don't use curly brackets, I'm only allowed maximum one line, one statement to execute. So if I don't have that print statement, then these two work. How do I want to write this? No bracket logic equals only one statement allowed. And that statement for this is return A, and the statement for the else is return B. Okay, that's one way of doing this. So now I'm going to comment these lines out. There's a couple different ways I can do this. I could do a multi-line comment where I say slash star up here and then star slash down here. That's one option. I don't know if I like that very much. I'm about to undo it. Fair warning. Undo, undo. Another way is I select all the code that I don't want to run anymore. And on Mac, I type command slash, like the one with the question mark, that slash. And then that just does single line comments and then it'll ignore that. So again, that's command slash. On Windows, it would be control slash, I believe. And so those are kind of two ways. Okay, so let's do this with our conditional operator. So what's our condition? For the max of these two numbers. A minus B greater than 0. Maybe this time I'll do if A is greater than B. Switch it up a little bit. So that's my condition. Then I need a question mark. And then I have, what do I do if it's true? Colon, not a semicolon. And then now it's a semicolon once I'm done with it. This gives me an error. So when we're using the conditional operator with return statements, the way we have to do it is think of the conditional operator as one unit, and it's like a mystery box, and we're gonna pull out one thing or another. So we're either gonna pull out A or we're gonna pull out B. And then we hand it to whatever the conditional operator, whatever called the conditional operator. And so what we have to do here is we have to say return, not equals. Just return. And then this whole thing is treated as a unit where either we give it A or we give it B. Let me add some comments while we're here. Conditional operator. Return. Has to go at the beginning. And so the way that you figure this out, if you know like how the conditional operator works, is you try something and then you're like, oh wait, no, that doesn't work. That means return has to go at the beginning. A lot of remembering things, especially at the beginning, is just trial and error. Okay, so that's max for two numbers. Let's do max for three numbers. So instead of A, B, C, instead of A and B, I'm doing it for A, B, and C. So how do I find the maximum of three numbers? Any ideas? Well, we can use what we've already got, right?
Have we supposed to do problem 3 yet?
Let me check. Yeah, you can do problem 3 if you want. That's not urgent. But let's continue with max. How do we find it? So let's say I've got 5, 10, and 11. Well, obviously looking at them, I know that 5's the biggest, or not 5. 11's the biggest. But how do I do that? How did I know that was true? We know the strategy for just two numbers, right? Look at two numbers, ask if one's bigger than the other. If A is greater than B, A is the maximum. Otherwise, B is the maximum. So we can do that again, right? We can compare the first two.
What about problem?
Problem 4, we're talking about that right now. So we know how to find the max of A and B. So let's use that. I could call the max method or just copy this logic. Either works. Let's save it as a variable D. So like the max of A and B will save to D. And then we know how to, then we're down to two numbers, right? There's D and there's C. So we know how to compute the maximum of two numbers again. So we've gone from three numbers where we just take the first two. We found the max between those. And then we're going to take that new one that we found and C and compare them. So then we're going to return If D is greater than C, we'll return D. Otherwise, we'll return C. So it's just another line using the conditional operator, where we look at the first two and ask which one's bigger. And then we save the result of the first two to some new variable. And then we look at that variable and the third number we've been given, because we know how to find the max of two numbers. And so we'll find the max of those two and return the result. So for 5, 10, and 11, we look at 5 and 10. 10 is bigger. Now we look at 10 and 11. 11 is bigger. Return 11. Okay, so now we've overloaded max as well. We've got one method named max that has 2 parameters, another method named max that's got 3 parameters. Let's test it out. Yes, that is correct. So if max is of 4 and 5, we're going to expect 5. And then if we find the max of 5, 10, and 11, we're going to expect 11. So if I run that, first I get 5, then I get 11 as expected. Okay. We'll stop here. It's a little bit early, so come up if you have questions. I have office hours tomorrow from 10 to 12. Is that correct? Let me check my calendar. Yeah, 10 to 12. Stop by. If you're not available during that time, book an appointment with me and I will be in my office and we can talk about it.
What about lab 2? Is that saved for Thursday?
Yeah, don't worry about lab 2 yet.
And what about, and what were you talking about before that?
Office hours?
Okay.
Okay, great. Thank you so much. I'll see you next time.